All right, the last two examples for this section in which we're dealing with area, in curves here, either between curves or bounded by the x-axis. I wanted to give two examples. They're similar, but I would say these are probably the most challenging. And let's look at why. In the last example, I told you where these two curves were bounded. Okay, in that example. This one I have no idea. So it just says between y equals x squared and y equals x. I wanted to do this first one because, we should know how to graph these really quick. And actually I'll do one in pink and one in blue. I kind of already knew where they were at, so I did cheat a little and draw this xy axis with only quadrant 1. But really, it doesn't matter where they lie. Okay, y equals x is this line. Y equals x squared, we know, is a parabola. Okay, very rough sketch, right? And what it's asking is this area, okay, between the two curves. Well, we know we set up the integral top minus bottom, and with this rough sketch I could tell actually the y equals x is going to be the top function, f, right? And the y equals x squared will be the g function, the denominator. But what we don't know is a and b, right? I don't know the bounds. So when we find the area between two curves, I need bounds, and then I do top minus bottom and integrate f minus g. So there's a little bit of scratch work to do before we get going on this. In order to see the bounds, we just need to know where they intersect. This one, just looking at it looks like 0, but we could verify that. If y equals x squared and y equals x, and I want to know where those two intersect, I would just set them equal to each other, right? Or think of substitution method. Y equals x squared, y equals x. I'm going to plug x in for y here and solve. Now, glancing at this, we could test values, like see, 0 would work, 1 would work, but really, let's verify algebraically. Get all your x's on one side, factor, and now x equals 0, x equals 1. So therefore, our bounds we are going to go from 0 to 1, and then f minus g, x minus x squared dx. Cool. Now it's set up. Let's rock and roll. Integral of x squared over 2, minus x to the third over 3. Range from 0 to 1. I love when we get 0. It's easy, right? Especially this one. We have nothing. 0 squared and 0 to the third is 0. So therefore, just substitute 1. 1 squared is 1 over 2, 1/2, minus 1 to the third is 1/3. Get an LCD, we'd have 3/6 minus 1/6, or 2/6, I'm sorry. So the overall area is 1/6, again, whatever unit they're talking about. Square units. Now, even with that rough sketch, right, we don't even need it too perfect. You do this algebra over here, get your bounds. If you're unsure which one is top, subtract them. If you get a negative, make your final answer positive. It will come out the same, right? Because all that would have happened is these two would have been flipped here, and therefore I would have had 1/3 minus 1/2, and I would get negative 1/6 switched to positive. Awesome. All right. Next example, a bit more complex. Wanted to do 2. 8x squared is a very, very steep parabola, right? It's still a parabola, it's still a U, but that 8 means it's stretched vertically. Square root of x, if you don't remember this graph, again, that's okay. You could just plug in a couple values and kind of see what's happening, but it does this. Now, this was such a rough sketch, right? I have no idea, but the bounds here. Like, I will say if I did 1 here, then this would be 8. Right, this intersects way up here at 8. 1 squared times 8. If I substitute 1 in here, square root of 1 is 1. So you could tell that's definitely not to scale, right? Like, I want to even erase that one because, oh, darn. It's very misleading. So, rough sketch, we want this area between the curves. Gonna need some algebra again. Again, this rough sketch maybe wouldn't technically have to do. I think it's a great idea for a visual though. So off to the side, we're going to set these two equal. 8x squared equals the square root of x. Okay, to solve this, let's go ahead and square both sides. So we would have 8x to, or I'm sorry, square the whole thing, right? 64x to the 4th equals x. Solving for x, we have 64x 4 minus x equals 0. All we can do is factor out that x. So this yields x equals 0. We're going to have to set this guy equal to 0. Add 1 and divide 64. Cube root it. Cube root, we do not need the plus minus. So the cube root of 1 is 1. The cube root of 64 is 4. Right? 4 times 4 is 16 times 4 is 64. So now we knew this intersection, like I said up here, was not drawn a scale. It went to 1/4 and it started at 0. Alright, let's do our integral. We know the bounds now, 0 to 1/4. Again, if you don't know top minus bottom, that's okay. Just reverse your answer. But I could tell even my rough sketch, the square root of x is the top function. But when we integrate, right, let's change it to x to the 1/2. Just like derivatives, just easier to think of that way. Subtract 8x squared dx. We really can't do much with that, so let's go in and integrate. X to the 1/2, add 1, we'd have x to the 3/2 divided by 3/2 or multiplied by 2/3 minus 8x to the 3rd over 3, 0 to 1/4. Again, we lucked out with this 0 here, right? I don't need to substitute 0, they're both going to be 0. So substitute the 1/4. We have 2/3 times 1/4 to the 3/2 minus 8/3 1/4 cubed. Okay. 1/4 to the 3/2. Let's think of that off to the side. We'll do it down here. So 1/4 cubed square root. Right, the 1/2 is the square root. The 3 in the numerator is cubed. Okay, either order works, right? We could do square root of 1/4, that's 1/2 to the 3rd, or you could have done 1/4 cubed, which is 1/64 square root. Either way, the square root of 1/64 is 1/8. 1/2 cubed is also 1/8, right? So it doesn't matter. So this piece here is 1/8 times 2/3 minus 8/3 1/4 cubed. We just did that down here as 1/64. Okay. Any cancellation? I definitely want this guy to cancel over here. 8 and a 64 goes 8 times. I could cancel this 2 and 8 on the left, but I'm just kind of looking forward. I see over here I'm going to get a 3 times 8, and the LCD would be a 24, right? 1 over 24. So I'm just going to keep it over here. So 2 times 1 is 2 over 24. 2 24ths minus 1 24th is 1 24th. That's a very small area. Remember, they intersected, and my graph was not accurate at all, but they intersected at 1/4. This area here, not drawn a scale, was really small. So 1 24th, the last one was quite small as well. Square units, or units squared.